I was just wondering because I've met Anji people from all over the place, and I was just wondering which location you were attached to.
Yeah, I'm remote, so that's where I'm at for the
Okay.
moment.
Yeah, we're kind of scattered around. I'm remote as well. I'm down in San Antonio.
Now, see, that's where I'm used to most of the people being from. I guess it's from the days before Anji acquired you. I dealt with some of your BD folks down in San Antonio.
Or Houston, maybe.
Maybe.
Is there an office in San Antonio, Scott? You're not in an office.
No, but there were a number of us working here out of San Antonio remotely, and
Okay.
and a few people up in the Austin office as well.
Hmm. What was the name of the company before Anji acquired you guys? Solaire Direct or something? Is that right?
Yes, that's correct. Solar Direct
Yeah.
USA.
Okay. All right. Well, we've got
All right.
about 400,000 square feet to cover in an hour, so.
Yeah, let's go ahead and get started. It looks like we've got Hardik on, who would likely be involved in a FAT once if we did it this way. So so let's go ahead and proceed. Thank you.
Sure. We did a full FAT on Monday with another customer for a building that shipped out yesterday. And just to give you a perspective, this was their lead engineer. He said he came in with incredibly low expectations, and by the end, he was like, "I should have sent you guys a full testing portfolio of things I wanted you to do." Because if 0 is no test and 10 is doing it in person, he goes, "This was a solid 8." So from that perspective, different customer, we think we have the virtual FAT down pretty well. All right, so what I wanted to do is I wanted to walk you through the diagram that I showed you last week. I don't yet have the ability to pull the diagram up in here, although I will at some point. So I asked you guys to remember back to 2 weeks ago, and I showed you the flow of the plant. So we're at one corner of the plant. We're going to call this the southeast corner of the plant. And we're sitting where we have receiving for our panel section. So our panel section, as you can see, all the material that we're going to put into panels, and we do about 6,000 panels a year, comes in through those 3 doors over there, which is a shipping bay, or through this door over here, which is our FedEx, UPS, Amazon bay, right? And so then once they come in, this is all a homemade storage and inventory processing system. And the idea here is every single piece, because we're a lean manufacturing organization, every single piece that resides inside here is dedicated to a single panel. And each one of those pieces gets a barcode so that we know which piece goes with which panel. And then if you look to this section here, you can see that we have these different carts. And so each panel becomes a cart, and each cart gets a packet. And that packet corresponds to the drawings and our quality control document that's going to travel with that panel. Now, I'm not going to show you I think it's exciting to some, but not that exciting to others. The raw material for our panels comes in on the other side of the wall here, and that's where we have our press brake, we have our former, we have our laser cutting stations, we have our grinding and welding, and then it moves over into paint. We're going to show you the paint system in a little while, but I just wanted to show you the flow of the panels. So a panel, before it gets released, and just one other thing, this is a controlled area. So during the off hours, not on first shift, this area is locked. If you don't have a need to get in, you don't have access. So for instance, I don't have access to this area because no one needs me to pull parts for panels, or at least if they do, we have big problems. So from that standpoint, that's a controlled area, so that helps with our SIP compliance when we talk to utility customers. So now we collect all the equipment that's going to get integrated into a panel, and it goes on one of those carts, and then it moves across the barrier. And once it moves across the barrier, we go into major component assembly. So through this blue door, that's where we have the cabinets that are assembled after the steel is cut, formed, cleaned, painted. The cabinets are assembled, and they come through here, and you can see at this stage, this is when we add the major components like relays, switches, DIN rail, and other components, as well as terminal blocks to the cabinet, and it starts to look like a relay control cabinet. Okay, now you can see there, every single one of these stations has a computer, and all of the drawings are done on computer these days, so that as soon as the drawings are updated, we're always dealing off of the most current version. So if there's any change, it's immediately reflected on the drawings that these guys see. Okay, does that cause a little bit of confusion here and there? No, not really. We have been able to work on that revision control, and if there's a revision that changes a part number, then these guys go back. They would come over to the inventory control, see if we have that that part, and if not, then we would have to order that, and it would get put off to the side. So panels awaiting work go into this area right here, and I'm assuming that you guys can see my laser pointer and the circle. Yes?
Yes.
Okay, good.
Yes.
All right, excellent. And let me just take a minute here and do a little orientation. So when you guys are looking at your Teams window, you should see a Teams window, and that window at the top should have an arrow on the far left. It should have a ink button or a pen just to the right of that. And then about 2 or 3 over, it should have a trash can. So if there's something that you'd like me to stop or concentrate on or to look a little closer at, what you can do is you can click on either the ink button or on the arrow button, and then you can draw or put arrows on my screen. So if you guys wanted to try that right now, someone on the phone could put an arrow on one of the monitors that you can see from my view. If you guys wanted to try that. Somebody try it.
I tried, but it's. Do you see anything?
I do not.
Hello, Hardik. That's me. I'm Alexi. I succeeded to put the arrow where I want to.
Oh, I see.
I
Yeah.
put an arrow too. I don't know what's that box. Not important. I'm just so trying the arrow.
You guys, are you doing it?
Yeah.
Yeah,
Do
can you see
the
it?
yellow?
I don't.
You see the
Okay.
yellow arrow?
Yeah.
I'm
So you
pointing to a
guys see it,
chair.
but I don't.
I'm just pointing to a chair.
Huh. That's crazy, because normally I see them before you guys do.
I think we all only see our own arrows because I put 3 up there now. How do I? You
Okay,
can
so
just
then
trash
to
can
get rid
them.
of them, yeah, you trash can them. All right, well, let me get a little closer to something, and maybe it'll work a little bit better. But anyway, so that's some of the interaction that we can do. All right, so you can see that at this point, we're trying to. There was a little spot weld of a. Normally that happens over in the sheeting and forming area on the other side of the wall, but occasionally you have to do a little bit of work over here. So that was a stud, probably a threaded stud that was added to the panel there. So then, after the major components are installed, you can see that there's no wiring in the back of the panel. All right, so it goes from this station and it moves over into the wire prep area. So in the wire prep area, we have a high technology piece of equipment here that helps us with our wire machine, for pre-cut wire machine. And it's highly calibrated, very technical, piece of rope. So that piece of rope allows us to measure what they should look like, and then you can see the wire technicians are adding that to a spreadsheet, and from there we come down to the automated portion of our wire. Right, so on the automated portion of our wiring station, what we have is these 2 different machines that can pull different colored wires. Of course, the main wire we use is a gray wire, gray SIS wire, and then it also prints out the the wire labels at the same time. So here you can see one of our wire technicians cutting the cables to length, labeling them, and then the same machine will also terminate them and put the right type of lug on there based off of whether or not we can terminate it now, or it won't put it on there if we have to terminate it over into the actual wiring area. So a lot of people ask us, how do we calibrate this area? And the answer is we calibrate it with every shift and every job. So as you can see right now, we're putting some terminations on those cables right there. And what we do is we do what we call a crimp test. And I'll show you that and what that looks like a little later. But every single person and every single job, so every job they do, they would recalibrate this machine by doing a practice crimp, and then they would do a pull test to make sure that that is still calibrated to the proper tension. And then every time that person changes jobs within their shift, they recalibrate the machine again. So you get it every shift, and then you get it every person, and then you get every device or crimper that they use each time as well. So if they were to change crimps, they would redo the pull test. Now we have a quality document that travels along in that packet that I showed you at the beginning. That quality document is called the QC18, and it's going to stay with the panel through the entire process. And every one of those crimp tests is recorded on the QC18, and you get a copy of the QC18 at the end of the project. If you're ordering a standalone panel, you get it with the panel. If you're ordering a building like you guys are, then you get a QC18 for every one of the pieces, and you also get a QC18 for the building, and that turns into your overall quality document. Now, each one of these steps that we covered has a sign-off. So there's a sign-off on the QC18 before the equipment leaves the inventory area. There's a sign-off each time that it passes from major assembly to wire process, from wire process to automated wiring, and then once we get over to wire. So that QC18 becomes a pretty important document throughout the life of the project, because what it allows you to do is trace our quality all the way back to the individual operator and individual process that we are conducting at the plant. So now we're into the wiring station. There's 48 separate wiring stations, and they're all set up exactly the same for lean manufacturing. So each one of these stations can be operated at all three shifts. And so right now, this factory is incredibly busy. And so we have nearly all the stations manned on all the shifts, and we're actually in the process of hiring as many people as we can. Now on the far side, you'll see that we have our visual process board, and that visual process board tells us where each job and each project, overall project, and each panel for those projects is physically at any given time. And so we can see there, that's the awaiting process. And then if we move a little further down, we can see here, these are panels that are actually in a station. Each station has its own line. And then as it gets closer, the 24-hour station, the 16-hour station, the 12-hour station, the 8-hour station, and the 4-hour station, as the panel progresses closer and closer to being done, the badge for that panel moves across the board until it's complete, and then that tells the supervisor how to schedule the next panel and when to schedule the next panel for that particular cubicle. Now, I mentioned we're doing a lot of hiring, and I happen to be on the mezzanine above our panel process line, or what we call value stream. So I'm going to turn slowly so as not to make you all sick. And when I do, you're going to see that we have an academy, which is where we train all of our wire persons. So all of our wire persons spend 2 weeks in this academy, and you can see that we have sample panels for them to work on, we have wires for them to work on, and we have stations set up similarly to how the stations are going to be set up in the cubicles. So every wire person has to come to the academy and pass the 2-week training, and then they move down to the floor. So they're not allowed to work on customer projects until they've gone through this training process. And this is one of those QC checks or quality checks that we do to make sure that the wire persons that work on your panel are qualified to the level that we believe they should be. One of the other things that we do, and I'm going to try to do this slowly, is we train our people on what a good crimp looks like, and then specifically for each customer. So you can see we predominantly use Burndy and Thomas and Betts lugs. There we go. That's the right word. So that's what we commonly use. And so those are the ones that we have here. But the other thing we do is we do one of these sheets. These are called method sheets. We do one of these sheets for every customer. So the more times we work with a customer, the more specialized these method sheets get and the more accurate they get to exactly what you would want your panels to be constructed. Because as I think I've told you guys before, we don't build systems control panels. We build your panels at the system control facility. And the method sheets are what allow us to do that. And that training for understanding method sheets starts here in the academy as well. So before I move on, I want to stop and solicit some questions. Is there anything that you guys would like more information on? Are you still there?
So the control enclosures are manufactured in a different area, right?
Yeah, and I can show
Those are
you that
just
area.
panels.
I just only have an hour, so I had
Okay.
to cut. But everything is done. We're 100% vertically integrated. Everything is done physically here on site.
I see.
And we're in Iron Mountain, Michigan.
Okay.
Okay, I'm going to move on. Feel free to stop me and ask questions. This is much better when it's interactive. And so, but what we are going to do is we're going to move into this far area here. And so I need to carefully move down the path. And so my spotter, Dustin, is going to make sure that I don't trip, fall, hurt me or, somebody else, but mainly me. All right. So moving around the corner here, and this is an opportunity to see more of the wiring area. Now we use Kanban systems for these for the smaller parts, and you can see that we have Kanban stationed all throughout the wire process area, the wiring area, and that allows for easy access and faster production. So the next area we're going into is a controlled area. This is our electrical testing. This is one of the things that we think makes systems control a slightly different type of manufacturer than most. All right, so the first thing we do in the panel electrical testing area is we do a continuity test. Some people talk about a point-to-point check. We don't think that a point-to-point is really useful for a panel. We think a continuity is more useful. So what we do there is if there's a circuit that goes all the way through the panel, say it starts on terminal block 2B and it goes through a relay and then ends up on terminal block 5D, the real idea is that there's continuity through that entire circuit. And so that's what we test. So we use the wiring diagrams to be able to do that. And you'll notice as we look at different drawings throughout the plant, the wiring drawings are all done with orange. We're going to see the house drawings are going to be done with green. And that's how we can tell what's been tested and where. Any questions? Okay, we're going to go talk to Mark Cavallari. Mark is one of our electrical testing engineers. One of the interesting things here is that we actually have engineers that do our electrical testing. And we have test benches that are set up with all different types of test equipment. And we feel like we do a much more complete version of electrical testing than most suppliers. All right, Mark, we're coming. All right. All right, there he is. All right, so would you? So Mark's going to be talking through the separate speaker so that you guys can hear him. So go ahead, give us a. Yeah, it's probably easier if you hold it. So go ahead and say something so that introduce yourself so they can make sure we can hear you. Can everybody hear him?
No.
No, I can't hear him. Nope.
Are we muted? All right, try it again. No?
Not yet.
Nope.
All right, well, this is our first technical snafu.
I think it came through.
Oh, we can hear you now.
Now you can?
Yeah.
Okay.
So go ahead and tell them what you're doing here on this panel and what our electrical testing process is. You got about 2-3 minutes.
2 or 3 minutes. I can do it. First of all, when I get the panel, it's already been full continuity test to the schemes. They go and check every wire from point to point to make sure that it's landed where it's supposed to be before I power it up. And then once I get it, I'll go through and I'll check all the relays for the correct voltage before I power it up. And once I verify all that, I'll energize it. And then I'll start testing to the schemes. I do all the inputs, all the outputs, anything that's wired out is going to get energized and tested. And and also then I write down firmware version on these and serial numbers and that kind of thing. And if it does need different firmware, I'll change that in the relays as well. Once the DC portion of it's done, then I'll start the AC. I inject currents and voltage into the PTs and CTs and make sure that the readings are correct. And then once that's all done, the last thing that we do is we'll do a functional test on these. We'll put a fault on it just to make sure that we'll get an output to pick up. And then once that's done, then it goes to post-test and gets graded and away it goes.
All right, any questions?
Hello, yeah, I had a question. So would we ever expect to need to update the firmware on anything in the life of the panels, and how is that done if so?
Well, each customer has their own firmware that they want, and if for some reason it's not ordered with the right firmware, we can change it here just through the computer. So each customer has their own firmware that they use.
So I think a way to answer that question is somebody like Adriana would specify a certain level of firmware that they want installed. And then for the life of your project, that firmware should be okay unless SEL has some type of issue, in which case SEL sends out a mass notification and they would send a technician to your site to be able to flash a new version of firmware, and it would have to be retested at that point. But from what we see, the vast majority of relays that leave our plant that go to renewable type projects never have another type of firmware installed. It's optimized, tested to work with that firmware, those settings, and so everybody leaves them alone unless SEL comes out with some type of a problem. I don't know if you want to add anything to that, Adriana?
No, I'm good. That was a good explanation.
I have a question. Alex is speaking from NG Solar. Is the program and the parameters that you set within these relays are the final ones, or are these just for testing purposes?
These are just for testing purposes. We don't put the settings in the relay. This is just the default settings. And then once the customer gets it, they'll put their own settings in.
Okay, so
very rarely we have 1 or 2 customers that actually ask us to load up real settings. But generally speaking, we're just using default settings to do that. If you wanted us to load the full settings, there's 2 things that have to happen. One, you actually have to finish them, which usually doesn't happen before we ship the panels. And then the second one is we have to have them here in time before they get shipped or integrated into the building. So those are the 2 things that have to happen.
okay, thank you.
Sure. All right. So just to show you because we're going to see this over at the building testing area, but just to show you the resolution of the device, the HoloLens, can you guys all read the LED screen there?
Yep.
Mm-hmm.
Yep. And can you read the
Yes.
white writing?
Yeah.
Okay. And so, and if we want to go up or down, we use the human zoom, and it works out really well. Okay, and then just, I'm not going to go behind this relay because it is probably energized. But what I'm going to do instead is I'm going to go to a different relay here in the testing area and show you guys the workmanship on the back. Okay? So any last questions for Mark? All right, great. So
No,
you can put
thank
that
you.
one back on mute. Hey, thanks, bud. Oh, no, we're not allowed to do that. Sorry. No more shaking hands. All right, so I'm going to show you. This is the back of a panel. Now this is a back panel that has a back plane on it. So we've got the fuse panel on the back. I don't believe your panels have that, but if I get close, you can see very clearly the wire labeling, and you can see the way that the wire has been trained, and you can see the workmanship in terms of how the lugs are set up. You can see what the selector switches look like from the back. And this is a pretty well populated panel. So you can see quite a bit of wiring has been done on this. Any questions or anything you'd like me to zoom in on closer on this panel, even though I know it's not yours?
I was trying to do an arrow just to see if it would work,
Oh.
and I'm not getting it to do it now.
You know, I wonder if I have to set up the meeting for that. Because when I set up the meeting in the past when we were doing all this testing, the arrows from the audience worked really, really well. So yeah, maybe next time, now that I have Teams, I'll set up the meeting, Kevin, and maybe it'll work better.
Okay.
Sorry about that. Okay. Anything else you guys would like to see here? If not, there's one more thing I'm going to show you in panels, and then we'll move on. Okay, going to move on. And Dustin is making sure I don't kill myself. All right. If you guys could see me walking, you'd be laughing. I am trying to do my best. Don't bounce your head walk. You're going to have to get the door. All right, so this station is our final test station for panels. Everything gets re-verified, and this is the last check that you'll see on a standalone panel on the QC18. And then once it passes the final test, it moves from here into the shipping area for panels. Now, you'll notice that we can ship panels a variety of different ways. I don't see any tombstone panels here. But we call the tombstone panel is the one that coffin type panel where it's lengthwise on the ground. But we can do OSB or we can do cardboard. Now, customers that have been with us for a while have moved almost exclusively to cardboard. Now this is for standalone panels because it's very difficult to dispose of the OSB in the field. And so as a result, they prefer being able to dispose of the cardboard. In your case, you're ordering a turnkey building, so all of these will come fully integrated into the building right up front. Okay, so I'm moving around. I'm going to walk through what we call our compact integrated solution area. You can see a terminal board, terminal cabinet here on the side. These are also done over in the panel area because there's a lot of wiring that we can do ahead of time in a terminal cabinet. But the compact integrated solution is actually very useful for renewable projects, just not renewable projects quite the size that you're doing. What we can do is we can take one of these, and you can see these are full-size panels. These are exactly the same panels that you just saw in the testing area. They're just mounted in our CIS so that you can keep all of the same designs that you had before. And the difference is we're able to put a battery charger, an AC panel, a DC panel, and a small set of batteries into one of these units. And then we can tie these units back to back to where you could have up to 5 bays back to back. So you'd have 10 total bays. That typically allows you 7 or 8 relay panels and then a full set of batteries as well. And so I'll just walk you through this area. Some of our customers have taken to this idea very quickly and aggressively. Others have not. And the key difference between the two customers is some customers are more field centric, meaning that they would like their field crews to have a place to go and get out of the weather. And other customers have looked at it and said, really, these sites are only supposed to be occupied about 1% of the time. So I'm okay with my field crew not having a place to get out of the weather 90, for the other 99% of the time, because they shouldn't really be out there anyway. And so these are all examples of the 4-bay CIS. One of the nice things about the CIS is that they all come with HVAC. So you get heating and cooling just as if you were in a building. At least the components do. As well as rack-mounted HMIs. And then the other part is all of them come with a terminal cabinet. And so our job when we look at this is we do all the inter-panel wiring, and then we wire everything out to a terminal cabinet. And then all you have to do as a customer is come in from the bottom or the side of the pad on the CIS, and all you do is land your field cabling in the terminal cabinet, and everything else is already tested here at the plant. So it's a very quick startup. But again, the key difference is you don't have a place to get out of the weather when you use a CIS instead of a substation control building, and you can really only do it if you have 7 panels or less. Does that make sense?
So what's the typical size of projects you see customers having CIS?
So, I'm sorry, repeat. I had my volume turned down, so I didn't get an echo. Would you please repeat that?
Yeah, so what's the typical size of the projects you see customers preferring CIS or the entire building?
Yeah, if it's 25 megawatts or less on solar, we almost always see people do a CIS. We've had actually a 100 megawatt job done, but it was the string sizes were abnormally large. So it's a little bit of a design issue, but anybody that's doing 25 or less, once they see the CIS and they understand it, it's a no-brainer. It's super easy.
Okay.
And let's say you broke up your 100 megawatt site into smaller chunks, you could have a CIS stationed for each smaller section. The savings is pretty significant. I'll give you an example. The customer that uses these the most on solar, typically the house was somewhere around $400,000, and they're paying about $250,000 for a CIS. So $150,000 is pretty significant savings, and you get exactly the same capabilities because you get exactly the same panels. The only difference is you just lose that ability to have a site out of the weather.
Yeah, your installation costs would be cheaper too, I'm sure.
Yeah, that's the other part is I don't get to see that part of the installation, but you're right. There's no big concrete pad. You don't need a crane. You can do that with a boom truck. And the installation, you don't have to run anything inside a house. You just run it to a term cabinet. Okay, so I moved on pretty quickly because we don't have a whole lot of time. I could have lingered there a bit more, but I know this is what you guys are most interested in is the house area. So this is our EE construction area. So if you remember the diagram that I showed you before, about 25% of our plant is behind my back right now. And that is all the panel area. And so about half of the panels, we make about 6,000 a year. About half of them get shipped out through the shipping area as individual panels, and half of them come into this area to be integrated into a building. So I'm going to take a step forward here. Raw materials for the building come in through
Hello?
We lost you.
We lost the presenter.
these back. Oh, shoot. Am I back in yet?
You're back now.
I'm back? Okay. Where did I drop off?
As soon as you looked into the raw material building.
Okay, so on the raw materials, they come in through here, and the raw materials get deposited here for base fab. this is where we fabricate all our bases. I'm not going to stay here too long because that grinding guy is making it really hard to hear. But the C channel comes in here and is cut to length. The floor, the steel plates that we use for flooring are shown here, and they get put together down at that other end. Going that way, all right. So just like if you've ever seen a locomotive being assembled, the bases get assembled the same way. They get assembled upside down. So we start with the underside of the base, which means we put the steel plates down first. So if you look over here, you can see, don't look at the guy doing the welding. The grinding's fine, but don't look at the guy doing the welding. We're not sure if that translates through here yet, and it would hurt your eyes. So on that, we've got the steel plates down first, and then they take the C channel, and they have exterior C channel and then interior C channel, and the design is all dictated by our structural engineers. And where we're going to put the batteries, there'll be more cross member C channels, and where there are less or no batteries, you'll have less C channels. But it's all designed structurally right there, and that's where we put it together. So moving a little further down, I'm going to take you past this area here, and I'm going to take you over to our wash booth and our paint booth for the bases. Okay, so we're going to come down through here. Dustin's going to make sure that I don't go anywhere I'm not supposed to go. Howdy. Okay, so we're coming in through the backside. And in the paint booth, we don't have a base in the paint booth right now. But this is where we do clean, we paint the bases, and we also dry the bases. So it's a 3-part process inside the base fab paint booth. Hi. Coming over to this side, you can see that we haven't yet turned over the bases, right? So before we put this sheet on here, and the sheet that we have on here is our rodent barrier. This is a 24 gauge galvalume rodent barrier that goes across the entire bottom. But before we do that, whatever type of insulation you've requested, whatever R value that is that you want on the base, we insert either this amount of batting or firm foam or blow-in foam, whatever is required to be able to reach that R value. Now, the panel, the factory is incredibly busy right now. You'd almost never see us stack the bases on top of one another like this. There's nothing wrong with it, but that just goes to tell you exactly how busy it is. Now, these areas here are where we attach the casters. So the casters are how we move the building throughout the rest of the plant. So this particular building is going to get 10 casters. Now, how can I tell who this building is for? How can I track quality? What does that look like? Well, we're going to walk down the side of the paint booth, and we're going to show you that. So this paint booth can accept bases up to 74 feet long. That's the longest single base that we can do. After 74 feet, we have to divide the base into 2 pieces and rejoin it at some other part or some other point. So each one of these projects gets what's called a pod. Thank you. And this pod is here. So you can see that this is project 49160 called Carmichael. And this is going to be a 24-foot by 60-foot building. And that is a 2-piece building, but it's only 1 piece lengthwise. It's 2 pieces widthwise. We can go up to 16 feet of width in 1 piece, and we can go to 74 feet long. So we can get the length, but we would need 2 wide on this. So what you're going to see is each one of these buildings has a quality and an inspection issue board, and that's right up there at the front. And you can see that during fab, there was a silicone verified at each one of those locations to make sure that it was sealed properly. And each one of those has to be signed off and worked on. Now, your buildings, like a lot of buildings, require a state certification. This one is going to Texas. So to qualify for the Texas medallion, we have this series of processes that we have to have checked off by a third party. So we hire a third party to come into our plant periodically and check each one of these areas. And then as we check those off, they then issue us on behalf of the state medallion. So this is a pretty thorough process, and this has to be set up and approved for most states prior to us beginning manufacture. So all of that has to be set and approved. Okay, so on the back side of this is also a complete set of drawings for the project. Now, here we only have drawings for the customer building portion of the project, right? There are going to be panels that go into this project, which are those packets are currently with the panels and will eventually be joined back up with this pod once we get out into the building integration area. If you guys have any questions, this is a good place to pause. Are you still there?
Yes, sir.
Yep, still here. No questions.
All right, great. Okay, so we're going to move down this area. One of the things that we have is we have information boards all over the facility. This is one of the ones that we've just put up and reworked. We just had 1 million hours worked with no lost time accidents here at the plant, so that's something we're pretty proud of. We have an ice cream social that we're doing for all the workers next week to celebrate that, and we also got shirts. And then over here, these are all of our safety captains. We have a program for safety that we call Coach, and that means that each one of these areas has a safety captain that are not, they have other jobs as well. This is an additional duty, but we're celebrating all of the different captains that we have for what they've done. Okay, so what does a base look like when it comes out of paint? Well, it looks like this. You can see that the casters have been attached. Right? These are the grounding plates. The grounding plates were covered so that they didn't get painted over. And so then at some point we'll take the paint off of that so that you can see it. Each one of your buildings is going to have the project number welded into the frame. And that helps you if you ever have a need to communicate with us. We track every single thing, including the panels and the building via this number right here. And so it can't be erased or lost. You're always going to be able to have that. Now this is going to be a two-piece building. How do I know that? It's this area right over here. This area over here has been left bare because when we put these two together, they'll be butted up like this, and then there'll be a plate that goes over the top of them, and it'll be, in this case, welded down. So you can see the batting inside. There'll be additional batting added after the joining has taken place. And then we'll also attach there's different attaching points, like screw points right there, where we will attach the two bases together once we set them in the field. All right, so this is you can see the thickness of the steel plate that constitutes the floor. You can see we don't have issues with squeaky or bumpy floors. These things are incredibly solid and well attached to the frame. This is a new paint system. We just added this paint system. We used to have a water-based paint, and we went to a solvent-based paint. The concept was to be able to do coastal without having to do anything different to the base. And so this is actually a coastal prep type paint that we can put another coat on it for when people want coastal, but we don't have to change paints or do anything different. So you get a much higher grade paint, and we just made that upgrade kind of the middle of last year. Any questions on bases? All right, going to move on. So at this point, you start to see the construction of the structure of a building. So we have the base, and now we have the structure. And what we have here is we have one wall has been assembled on this base. So on the wall, we use, it's a G60 cold form steel process. We've gotten away from welding because welding actually really limits the amount of flexibility you have in construction and really in support inside of a building. So not only do you get a galvanized structure, so it's not going to rust, but it also gives us the opportunity to be able to add additional struts and additional structure if, in fact, there's a need for something like 190 miles an hour wind loading or additional snow loading up in Canada or something like that. We don't have to change materials or do anything. All we do is this cold form steel process that's totally contained within the plant gives us tremendous amounts of flexibility, both in controlling our supply chain, because all we need are strips of G60, but it also gives us flexibility in terms of construction and construction practices. So that's one wall, and you can see how that has to be braced. And then we come down to this building, and this building actually has all 4 walls installed, and even our trusses are made of the same G60 material and placed on top of the building. So what we have here is we have our break, and I'm going to walk down this area here. This is the break between what we call the fast lane and the custom lane. So the fast lane are projects that are repeat projects or high volume projects, and they're typically single piece buildings. So the fast lane, the new construction that we opened in June of last year, is past this wall that you can see there in the distance. It's on the far side, and that's where the fast lane is. So once a project gets to this point where it's got the base and the structure assembled, we make the call between the fast lane or the custom lane. Notice we don't call it the slow lane, it's the custom lane. So our very large buildings, our unique buildings, our multi-piece buildings, all typically flow down the custom lane, and then the rest go down the fast lane. So I'm going to walk you down the custom lane, because if you can understand the custom lane, the fast lane is really just a much less complicated version of that. But to give you an idea of the scale of the building, we've walked about, I don't know, 1/3 of the total distance to the end of the building. So we've got quite a ways to go yet. How are we doing on
And
time?
our building is going down the custom lane, right?
Yes, your building is a
Yeah, we lost you.
single unit. So if we were to stick with the same size, because Bluestone and Whitehorn are the same size building, and Adriana worked hard to make sure that they're as alike as possible. If we were to do future work with you, we could potentially move it down to the fast lane. So I'm going to try to get back to the safety of the area on the other side of the yellow line. Before I do that, I'm going to show you a double wide building, a special double wide building. This is an offset double wide building. So what this customer has decided to do is to take all of their panels and put them on the wide side of the offset. You can see here when we look at the peak, this peak is twice as long as that peak. Right? So they take a double row of panels and they put them all down the far side of the building. And then they take all of their auxiliary equipment, the AC, DC panels, batteries, transfer switches, and everything else, and they put that down the short side of the building. Now, why do they do that? They do that so that when we ship the building, all of the interconnection wiring, all of the wiring from panel to panel, panel to terminal blocks, terminal cabinets, all stays integrated. You don't have to take it apart. The only thing you have to take it apart when you do the shipping split is the auxiliary equipment to the panels, and that's a much faster reconnect at the job site. And so that's what this customer has done to try to make their life a little bit easier at the job site. Now, you're not doing a 2-piece building, but maybe you might do one in the future at some point. And this is a pretty neat arrangement that this customer has come up with to be able to make that work faster in the field. Any questions on the offset building here?
Yeah, all conduits that are coming from the outside to the building, they are, let me say, designed and foreseen here in the factory, no?
Absolutely, yeah. Now, this particular customer, you can see that this customer is an upper entry, right? So this is going to be a cable riser. And I know which customer this is. I'm just not going to say their name, but what they do is they do a cable riser and come in the top. And so they'll have a conduit, whether it's some type of trenching or a concrete trench, but they'll terminate right here, and they'll come up into the riser, and then in the top. And in this particular case, they do not have a termination cabinet. They come into the top, hit the raceway, and go to all of the panels from there. But we do have a customer that does the same type of thing, that comes in up underneath the building, kind of right here as well. I'm sorry, up underneath the building, right here as well, into a termination cabinet. And they actually get even a bigger benefit from doing this, because we can wire and test all the way to the termination cabinet. And now all they're doing is just doing that field landing right there. It's there's a lot of customer preference that goes into this. That's why we say we don't build a systems control building, a systems control panel. We build your buildings and your panels at our factory, because you're not interested in how we want to do it in most cases. Okay, so one of the questions we get is about ballistic rated buildings. And what you're looking at here, this is a ballistic rated building. How do I know that? And we're not supposed to touch these with the bare hand. So this is a fiberglass ballistic wrap. And I know that this is a level 3 fiberglass ballistic wrap because it's 3/8 of an inch. If you wanted level 8, it would be a full inch of fiberglass around the entire building. Now we have customers that wrap the entire building like this, and I know which customer it is that asks us to do that. But we also have customers that only do either the portion facing the transformer, or they'll only do the portion facing the exterior of the yard. And that's just another personal preference thing. But this does add a ton of weight to a building. And so if you did a portion of the building, you're able to save some of that freight and crane at the job site. So a double wide ballistic rated building right here. Questions on that?
Yeah, ballistic is good, but what about the thermal insulation of the building?
Okay, so by thermal insulation, I'm asked 2 questions there. One is, are we talking R value, or are we talking about fire ratings?
R value.
R value, yes. So this particular customer, not that interested in R value, right? If they were, the highest R values that you're going to see are where there's a foam or a continuous installation, installation all the way around the outside of the building. And then there's the fiberglass batting or a spray foam on the inside. And then we put the interior panels in. This customer is only going to do batting on the inside. So if I had to guess, this is going to be something like an R19. But you can get all the way up to the 30s by doing the continuous insulation. And places like California require that, so that there's a thermal break between the metal and the outside, so it's less conductive, more efficient. But anyway, this particular customer is a relatively mild climate. So they're worried about gunshots, but not that worried about insulation. Like I said, personal preference. And you can see here, this is our fall protection. This is regularly inspected. Yep, what? Oh, that's right, yeah. I might drop here. This is one of the areas we identified as a little tough on the wireless. So we'll see what happens. So you can see here is another double wide building. In this particular case, the customer wanted an extremely wide, double wide door on this end as well. We never know exactly why they want that. Usually it's if they're going to plan some type of expansion. So if they're only going to have us put, say, 10 or 15 panels on a building this size, and then they're going to order more panels later, they'll want an extreme double wide so that it's easy to get future panels in and out of the building. Okay, so once we finish with the outside, every building gets a wrap. This is one of the other ways that we're really focused more with this wrap on water tightness than we really are on the R value associated with the wrap. And I'm going to talk a little bit about how we do water tightness in a minute. So one of the next things that I wanted to show you, because I showed you the panel academy, I wanted to show you our building academy as well. So same kind of thing. As we hire people, we bring them into the building academy, and at the building academy, we take them through here. This is how to do inner panel wiring and what that looks like. These are how we do crimps for the different types of wiring, because we're talking about different types of wire that go into a building. You have house wiring, and then you have inner panel cabling, and so the crimping is slightly different, similar but slightly different. So they get trained on that, get trained on safety. They get trained on how to put all the different types of junction boxes that we approve, how to put those in, and more importantly, how to mount them to our particular style of interior. So on the interior, we use a thing called a marquee panel, and you'll notice that there's no visible fasteners on the marquee panel. It's a seamed, but kind of very smooth type of construction. And then we show what the batting of the insulation, and then we show what that transition piece looks like to the outside of the building. Now this is what we call a multi-rib. A multi-rib is a 22 gauge exterior panel. This has a 25-year warranty against cracking, caulking, and fading. So all of the exterior panels that we put on all have that 25-year rating, and we make sure that we show them properly how to attach the fasteners to the outside, because this is not a concealed fastener type product, but we make sure they understand that. And then we talk about how we do roofing. So this is how you bring the exterior panels up to the roof. And then we talk about how do you install them again for exterior sheeting. And now we talk about the standing seam roof. So this is one of the things that makes a difference here at Systems. We've installed over 1,500 buildings in the field, and we have 0 leaks. One of the reasons why that's the case is the way we put our roof system together with the standing seam roof. So there's a crimping tool that comes over and rolls this over into the next piece. So along the edge of our, across the entire area of our roof, again, it's a concealed fastener type issue. You can see here, the only place we have fasteners are at the eaves, so it's already past the roof line. And so we have the opinion that if you don't ever put any penetrations on your roof, you won't ever get any leaks, and that's kind of been borne true. Then we have the roof the roof cap would go over top of this, and these wings are what give us the water movement, the water flow from the roof cap over into the standing seam roof area. And then here we show the employees how to do the insulation and how to set up the different portions of the roof system, the different type of insulation. And then we use this to be able to show all the different types of insulation and the type of R value that we can get to. So the reason I asked you about that is, these type of foam boards provide you R value. This type of insulation provides you R value. The sheeting is more about water protection. And then this up here, the gypsum board, each layer of 1 inch of gypsum board provides you 1 hour of fire rating. We don't often see too many people ask for additional weight on the roof, but we do occasionally see that. Most people would like the fire to burn through the roof as opposed to try to keep it in the building. But nonetheless, this is something that we can offer, and we do have some customers. This is the more typical roof construction that you're going to see with the foam board without the gypsum on that side. All of our buildings come standard with a gutter. We feel like that's a good use of the space there, and it helps the trim and directs water into a place where you want the water.
Hey, Dave, I got a hard stop at 11, and I'd like to see the rest of this, but how much longer is it going to take you to go through the whole factory? Like, we're going to see the final?
Yeah, about 20 minutes.
Okay.
Yeah, I could maybe do it in 15. I can speed up a little bit. All right.
No,
so
that's not necessary. I mean, I got to go anyway, but I was just wondering, maybe is this recorded? Maybe I could watch it later or something.
I actually did not record it because when I record it, it significantly reduces the resolution for the people on the other end of the phone while you're watching it. But I can do a recording at some point, or at some point we just get back on the phone for 20 minutes and start at the academy and move on.
Okay, sounds good.
All right. Is everybody else still good, or do we need to schedule a second session?
I'm good.
Okay. All right. So let me continue to progress here. I'm going to go back out. Hey, Emma. All right. So now I'm going to head back down and start looking at buildings that are more complete. So again, we try to cart as many things as we possibly can. That's a lighting cart. You have the junction boxes and all the lighting for a building. They're getting ready to install that. And normally you do not see this many buildings on the floor at one time. Normally it's a lot less congested than this, but this is the most buildings we've ever had under roof at one given time, and we now have 15 buildings outside as well. So on this building, this is the beginning of integration. So at this point, this building is moved down the line, panels have been placed into the building, and there's no power to it yet, obviously, but the crews have started wiring panel to panel and then panel to auxiliary equipment, and that's going to continue. This is the second longest period of time that we're working on a building here in the plant. So this is a tough process, long process. Let's see. So here's another similar building. This building is in test. I can tell because it's got building power attached. So when building power is attached, we're going to stay out of there for now because there's no lights on. We're going to continue on. A term cabinet. What's that? Oh, cords. Got it. Oh, shoot. I forgot to show you guys the... All right, I'll try to do it here. Okay, so one of the other ways that we work on our waterproofing is right here. A lot of the buildings that you'll see out there in industry, the area where the siding meets the base is a difficult area, and that's where you'll see a lot of water ingress. So one way we do that is this piece right here. It's a flashing that catches the exterior panel and goes up about 3 or 4 inches into the area back here, and then we have tape, butyl tape that goes up a full 6 inches, so that you have 6 inches from here to here, and then of course you have all of the Tyvek wrap behind it. So you have the protection of the exterior panel. If for some reason water were to find a way in, it's going to be repelled by the Tyvek material, and then from the Tyvek material, there's still no way into the building unless you get past the butyl tape and this flashing, right? So most of the time, for us, 100% of the time, the water comes down, hits this flashing here, and then just rolls off the building. The other part of that is how you do penetrations. So here we call this a duct-tight boot, and we call that a duct-tight boot because that's the name of the company. You see right there, hopefully duct-tight. So this is a little more expensive penetration than you're going to find from other suppliers, but again, we test all of our buildings and all the penetrations in our buildings, every design, to a ASTM 331 standard, which means we put a negative pressure, a vacuum on the inside of the building, and then we spray high pressure water at it for about 3 hours. And each one of these penetrations has to stand up to that. And what we found is just putting some caulk around your penetration doesn't pass that ASTM test that we're talking about. You need this type of boot and the type of seal inside so these penetrations really do stay waterproof. So those are the circular penetrations. And then the next thing people usually ask about, there we go, is a square penetration. Now this is a different product. I talked about before the multi-rib. This is a mega rib. Mega rib is 18 gauge, and you can see that it has the bumps more closely together than the multi-rib. Now, for our buildings, these provide absolutely no structural support whatsoever. So our personal opinion, we do whatever our customer wants, but our personal opinion is going to mega rib is a waste of money because you get exactly the same warranty against caulking, cracking, scratching that you do with the mega rib. You just pay more for the 18 versus the 22 gauge, and there's no structural difference. We take care of all the structural support with the superstructure of the building, not with the exterior of the building. And there are some suppliers out there where the exterior of the building really is part of the structural support, and it becomes important that you have 12, 18 gauge, 20 gauge, whatever that is, on the exterior of the building. So if you guys had asked for mega rib, which you didn't, then we would have counseled you to say, hey, are you sure you need that? Because we don't need it from a building standpoint. Okay, so how do we do our square penetrations? So if you remember back to the academy, we showed how we take the flashing and we put the flashing back about 4 inches all the way around the outside. We then take this piece of flashing and we put it over top so that any water coming down the outside is forced to flow outside of this sealed compartment here so that there's no way for that to get in. And then we have butyl tape all the way around this exterior. These type of penetrations have been tested to the same ASTM 331 standard that the circular ones have. And again, 1,500 installations of this type of building with no leaks. Any questions on our external penetrations or the mega rib versus multi-rib? Okay. I'm going to move on. That's also a mega rib building. And I'll show you a multi-rib here in just a second. All right, so I'm going to speed up and head down to one of our buildings that's getting ready to ship. What's that? Oh, thank you. Okay, so remember when we were talking about the cable riser before? That's what a cable riser looks like finished. There's a cover that goes on that, obviously, when we're at the facility, but that's a finished cable riser. Okay, so this is our shipping area. On the shipping area, the trucks back right into the building. We have a coordinated hydraulic lift system that lifts the building. There are no cranes, no overhead crane. And so that coordinated lift lifts the building up. The low boy drives underneath it, and then it lowers the building right onto the truck, and then it is secured and pulled out. Okay, so this building is as complete as we're going to see a building. I can tell because they've attached the grounds. So this is a two-piece building. This is one of the offset two-piece buildings. This is kind of the finished product where the cable tray, the cable risers go directly into the cable tray. You can see that the bus between the two pieces, the ground bus is now connected between the two pieces outside the building. It would be connected inside the building as well. The gutters are installed. These would be removed. And this door might be locked. Nope. Okay. Now, one of the things that this customer does, which we like, is the entire building is on the inside is white. So you're not going to be able to see it really, really well, but you can see that the panels are white. And of course, our marquee panels on the interior liner panels are white. Yep. And so you can see what that does. It really makes everything a bit brighter. And now you can see the two panels on the long side, and then on the short side, you have all the other equipment that could be installed and even a work area. Ah, thank you. So there you can see what the inside of this building looks like. All right, we're going to move on. Any questions here? Okay. And then I had talked about what the hydraulic jacks do in terms of lifting the building. These are the hydraulic jacks. We attach them to the underside of the building. We lift the building, and then we remove the casters. And then once the casters are removed, we're able to lower it right down onto the truck. Okay, so we're moving from the custom area over into the fast lane. So at this point, I was going to ask to field questions, and then the last thing I was going to do was go into that building, a little smaller than your building, but similar, and just show you that. So do you have any questions on the plan?
I do not.
Okay. All right. So just to give you an idea of what the inside of a building is going to look like, similar to yours. So on this area, we have the battery cables, the DC cabling. So that would tell you that the batteries are going to be installed in this area right here, which makes sense. We have the HVAC there, and then we have the exhaust fan here. Now, this is a pretty large exhaust fan for this size building, but again, it's what the customer asks for. And then up here for house wiring, we typically do a raceway, but this customer has asked for conduit all around the exterior of the building. Then we have the auxiliary panels and the battery charger, the DC panel, and then up here you have the cable tray. Then you have the SCADA panel, another server rack, and then in this case, this is going to be a 4-panel, could have been 5, but 4 panels, not heavily populated. If I get a little closer, you guys can see the type of labeling that they have on their test switches.
Hey, David.
Yes.
Well, this is Aaron. So this is what's most interesting to me when we do our final walkthrough via this. Will you find something that's really small print and just see, like, I just want to see when we go through, like, I actually could read that nameplate. So maybe that answers my question. But like when we're looking, like, in how steady it gets, to see if we're going to be able to, like, just pick something and then, like, hold on to it. Okay, that's pretty fantastic. Great.
Yep.
Okay, so we should be able to do a pretty good walkthrough of this building with the engineers and really make sure everything's in the right spot and is where it's supposed to be and stuff.
Yeah, some of the smallest print is on the terminal cabinet. Right, that print on the terminal blocks is pretty small. That's probably 10-point font. Can you read it?
Yeah, we can read that. So I mean, I don't imagine we'll need to see terminal blocks that close. So anything bigger than that, and we can read that. So that's good.
Yep. And then the wiring is still being completed on this one. And this is a customer that allows us to do SIS between the panels. Some customers require cabling and don't allow you to do SIS. But that's where we're at on this building. Okay, so guys, that's the end of the tour. Normally this tour takes about 2 hours. So I apologize. I skipped over a bunch of things that normally I would not skip over. I'd spend more time on. I'm happy to spend as much time as you want, either now or later, but I believe I've already surpassed the time that you guys allotted me.
At this stage, do you supply all the testing sheets for the individual panels and the overall building? And how long do you keep these documents within your factory?
So yes, you will get a copy of every single QC 18. So there's a QC 18 for each individual panel, and then there's a QC 18 for the building. And that QC 18 has the testing records on it. Now there's an exception to that. If you have a particular testing regime or testing program that you would like us to do, then we would perform that in addition to the tests that we normally perform ourselves. And then as we're doing that, remember on the pod, we're tracking the different, oh shoot. Can you guys see me?
Yeah.
Still there? Okay. I got a message saying that I was having an internet problem. Okay, so in each one of these areas, we're going to track the QC 18 for the building and the drawings on the pod, and you get an electronic copy. You guys still there?
Yeah.
Let me move out of this spot. So you get an electronic copy of the QC 18 for each one, and then whatever additional testing you want done, you'd get a copy of that too. Now, we only maintain that for 7 years. So after 7 years, we're going to purge our records. We'll keep the electronic ones, but we will no longer keep any of the paper ones. And then we haven't really come up with a philosophy on how long we should keep things electronically. But the paper ones get purged every 7 years.
Okay, my last question. We have seen that you are doing functional testing on every panel, and once you assemble the whole cabinets and the building, I presume that you are doing also some functional testing on.
Yeah.
Okay.
Yep, absolutely. There's in addition to the guys like Mark that you met, there's a whole another group led by a different guy that does the testing in all the buildings. And when we get to the testing in the buildings, they've got the Omicron relay test set. They've got meggers, ductors. They've got all the other different equipment that you would need. And they'll do functional testing no longer on the relays. So they don't functionally test the relay.
No.
What they're going to do is they're going to put at the terminal cabinet, they're going to say, okay, so we see a phase imbalance over here, and they typically rotate the phases using an Omicron input, and then they come over to the relay and they say, do I see the phase imbalance here at the relay? And the answer is yes, and they go, okay, so that should operate or send a signal, whether it's a continuous or a discontinuous signal, whichever one it is, to a different terminal block and force something to operate out in the field. So we can't obviously see whether or not the thing in the field works, but we can monitor to see if that signal is sent. It senses the condition, the relay sees the condition, and then sends the response. That's the type of testing that we do here. We don't test the physical relay anymore because we know that was done by our guys like Mark over in relay testing. Does that make sense?
Yeah. Good. This is an integrity test, integration test. Oh, very good. Okay.
Yep. And
understood.
The more familiar we get with a customer, the more the type of tests that you would do in the field, we bring in here. In fact, we even tell you, if you want, bring your field testers in here because they're going to like working here a lot better than, well, except for maybe in the wintertime. Iron Mountain's not that much fun in the winter. But they're still going to like working here better than they are out there in the field. And the more stuff you can do here, the faster the setup and the startup goes in the field. So we'll do as much as we can here.
Absolutely.
Honestly,
I'm interested with our SCADA panel. The remaining panels is S&C stuff, so they have plenty of testing and rechecking to do on site. Anyway, thank you for the explanation.
Sure, no trouble.
Thank you.
Any other questions?
I guess just in terms of production wise, when does Bluestone buildings start manufacturing?
I knew you were going to ask me that, Kevin, and I do not remember the date. I'm sorry.
Okay. Well, you sent the schedule, so I can look.
Yeah, they are not in production yet. I know that, but I believe they're supposed to hit production pretty soon. I just don't remember the exact date. I'm sorry.
Right.
I can get that.
No, that's all right.
Okay. Good. So let me. I have to ask you guys. This is the second virtual plant tour that we've done, and the first one was for internal people. So you're really the first virtual plant tour that we've done. And so if you guys wouldn't mind just giving me some honest feedback, because our estimation is that customers aren't going to be allowed to travel to our plant probably for the rest of this year. And yet it's important for people to understand scale, process, procedure, how we handle testing, quality, et cetera. And so my question for you guys is, you don't have to do it if you don't want to. You're certainly welcome to. But if you could provide some comments, that would be outstanding on ways that we could make it better. Anything you guys care to add right now?
Well, I guess for myself, I would just add, I think it's helpful. It's pretty cool to be able to see the processes and the flow of the work, I guess. In terms of doing a factory acceptance test or whatever, I'm not really the guy to ask, but as a layman in that, I would say sure seems like a very nice tool. So I guess I'd leave those questions to Hardik and Alexis and well, Aaron spoke to it too as well.
No, we are very grateful for this presentation, and given the situation and the COVID, this is really a jump into the future, I would say, with this virtual factory testing, I would say. I just have one suggestion that we might have maybe a longer presentation, an additional hour with our building, just to make sure that, let me say, our control room and our substation is good. But what you have done so far is great.
Okay.
Yeah.
Actually, that's a really good point. We do a 3D model of every building before we build the building, right? Because in the software that we use, what's the name of the software again? What is it? Creo. Yeah, Creo. In there, it'll tell us whether or not we have interferences and do all of our connections mate and all that other stuff. So one of the things that I want to do and I'd love to do with you guys is to take that 3D model and what Dustin has done is he's taken it in this situation, put it out here on the floor, and then blown it up to not quite full size, and then we can walk through it. And
Correct.
before we ever even start to build it, you'll get to look at the 3D model and you'll be able to say, and this is what one of our customers wants to do is, let me go through the bill of material and make sure everything's here. And so they go through the bill of material and they check that it's all there. And then they have the opportunity to move things before we ever even start construction. So if you'd like to do that, I wouldn't mind. In fact, I'm looking for an opportunity, so somebody willing to do it, to put the 3D model up, walk through it, and then of course once your building is in construction, we can do that with the real building as well. But if you're interested, I mean, I'd like to schedule that with Aaron at some point.
No, this is a very good idea, and it will be, let me say, it will complete the work that you are already doing, which is great. And I'm also interested to have a walkthrough. We are not asking the source files of the 3D model because these are proprietary, and I guess that your team they pass too much time on building these models. But if we can have a walkthrough, let me say, video or scene from the 3D model for our, let me say, for our documentation, it will be great also.
Okay. All right, Aaron. So let's put that down as a schedule item. Obviously, I can't take notes right now. I'm sorry. I hate to ask you to take my notes for me, but if you wouldn't mind, that'd be great.
Okay.
All right. Good. Anything else?
Hardik, any question?
No. So this was very thoughtful and very helpful. I haven't seen this state of art, I would say. And the only thing we can add in is maybe have like a detailed activities or schedule that what we are going to do or in this walkthrough that may help us to collect our thoughts in advance.
Okay.
Maybe.
Oh yeah, I should have done that. I should have put an agenda together of all the things I was going to show you. Okay.
Yeah.
All right, that's good. Thank you. That's part of the standard work I need to develop for other people to give this tour also. So that's a great suggestion. Thank you. Sure. I'll do that. Adriana, are you still there?
Yes, I'm here.
You always have good suggestions. Come on.
No, this was pretty good. Yeah, and yes, it was really good, and I did not actually expect it, and I think it's a good idea, especially in this situation that we cannot travel much, and yeah, very good.
All right.
Yeah.
Well, thank you. Thank you. All right. Well, if Aaron, I don't know if you had anything you wanted to add other than what you already did. Maybe Aaron had to drop off. Okay, Dustin, maybe you ought to take that note on the agenda. All right. Okay, so great. If that's the case, then I'm gonna sign off. And everybody, thank you for your time. If you have additional thoughts or ideas or suggestions, please don't hesitate to email me and let me know. Okay.
Okay.
Yeah, great. Thanks a lot, David.
Thanks, guys. Y'all have a great day.
Much.
Thank you.
You got it. Bye-bye. Remote assist, unpin. Oh my God, it worked.
Thanks, David.
Yeah, that was good, man. That was real good.
Hey, I didn't know you guys joined. All right.
Yeah, yeah, of course.
Cool. Good. Yeah. So do you guys think you can do this on your own?
It's probably gonna take some walkthroughs for sure. There's a lot of things that you're talking about that I'm like, interesting, very interesting. But yeah, I'm sure we'll get close.
All right.
David, one suggestion you referenced,
Mhm.
if they could see what you look like walking around and navigating through the building, I don't know if it's at all possible at the very beginning to have someone be able to, Dustin or someone be able to show a picture of what you look like with that HoloLens apparatus on your head. It's but
Yeah.
they'd get a sense of what you're going through to deliver the message that you are.
Yeah. Tell me if this works. No way. Does that work?
Oh, I can see you, but you don't have the lens on any longer.
Oh, that's right. Yeah, I don't have the lens on. Oh, shoot, you're right. That's a good point. All right. Okay, I can do that. I think it really helps if we do the meeting. That's something else we're gonna have to put on the. You did? Okay, yeah. Because like for instance, my my little slate here. Where did it go? Oh man, that slate. It's all there. It is. So my little slate here doesn't show the call, right? So I didn't even know I was on the call.
Yeah.
Oh,
Right. Yeah. So I couldn't do anything. I couldn't mute. I couldn't turn my camera off. I mean nothing. It was really weird.
is that because you said you mentioned at one point because you're not hosting that
Right.
it may have been an issue.
Yeah, because Kevin was hosting. Kevin Brink, the guy from Angie, he was the guy hosting, and so the only way we had practiced before, I forgot that he had sent a message. The only way we had ever practiced before was with us hosting. So that was, I mean, Dustin and I were running around like chickens with our head cut off, going, "Why can't we join this call? What's going on?" And we didn't realize that Kevin had to let us into the call. So yeah,
Got
a little
it.
weird, a little weird.
Hey, David, the only criticism I would offer is that when you started the base fab portion of the tour, you came at it kind of from the back end.
Yeah.
And in the tours that I've been involved in, you head over towards that wall where the west office is, and there was that aisleway. In my view, it kind of lays out the process of commencement of base fab through base fab, paint, wall assembly, insulation, whatnot, a little easier. You kind of went back over there after the paint.
Yeah, I think you're right.
But
Yeah,
it's a little
I think you're right.
confusing coming from that back end.
We were trying to do fast,
Yeah.
and so
Yep.
walking through that door and
It's
just
quicker.
keeping going
Yep.
seemed quicker, but I actually think it took longer because it was harder for me to explain. So I think you're right. I think that's a better idea. Anything else like that, guys? Those are great suggestions.
I mean, I thought it went pretty smooth, man. It's actually very clear.
It's incredibly clear. That's
Yeah.
the part that's amazing, really.
Yeah, I was very impressed with the way the system worked out.
Yeah. All right. What? Mute? I can't. Call? No, I don't want to call him. Oh. Don't know. All right. Well, guys, we got to drop off the call. But thank you for all the feedback.
All right, David. You guys have a good
All right.
one.
Yep. See you guys later.
Have
Bye-bye.
a great weekend. Bye.
I don't know, maybe just, but it's